Hi, this is Kiruthiga from Krishnaswamy College for Women. Today we are going to see transaction in RDBMS. A transaction is a logical unit of work that accesses and updates the contents of the database. The operations like insert, delete, update, or retrieve data are used by the transaction to access data. The transaction processing ensures that related data is added to or deleted from the database simultaneously. The main challenge in transaction processing is to preserve data integrity and data consistency. Concurrency in transaction. A database is shared resource accessed by many users and processed concurrently. For example, banking system, railway air reservation system, stock market monitoring, supermarket inventory, movie ticket booking and checkouts, etc. If the concurrency processing is not properly handled, it may create some issues like hardware failure, system crashes, deadlock, or slow performance. Transaction states in DBMS. The states through which a transaction goes during its lifetime, from beginning of the transaction to end of the transaction. These states are which tell you about the current state of the transaction and also tell how we will further to do the processing in the transaction. The transaction states are active, partially committed, committed, failed, and terminated. The beginning of the transaction all in the active state, and it keeps on executing the transaction. If the transaction is fully completed and successfully completed, it goes to committed state. The partially completed is partially updated in one end and another one is not completely updated. If there is any system crashes or resource starving, it stops the execution, that is abort the execution and go to fail state. In active state, if there is any starving for a resource or any thing happened to the system or system server down, like any problem is identified in the beginning of the execution, in the active state, the process abort the transaction and go to fail state. The committed the process which completely executed and permanently saved in the committed state, and it goes to the terminated, that is the transaction completes. Then transaction properties. Transaction properties is used for maintaining the integrity of the database during the transaction processing. Asset properties. Asset A represents atomicity, and B represents consistency, and I represents association, and D represents durability. Atomicity is a transaction. A transaction is a single unit of operation. Either it should complete the transaction successfully, or it should not do it. Then consistency. The transaction should maintain the consistency throughout the transaction and each and every state. Isolation. The transaction should be executed in isolation from other transactions. Like if T1 is started execution and uses the tables A and B, the transaction 1 should be complete all the operations, and then only the other transaction can access the databases A and B. Durability. After completion of the transaction, the changes will be made permanently in that database. We can retrieve the database even after the system crashes or system failure. Here, an example for atomicity. In this example, what we are going to use, account A having amount of rupees 1000 and account B having the amount of rupees 2000. Okay, here from A we are going to deduct, that is subtract amount 50, and we are going to add it in the account rupees 50 in B's account. Okay, in this these are all these are all the steps we are going to do in this T1 schedule. So we are going to read the value, that is read the amount in the account A, and we are going to subtract 50, and we are going to write the updated value, that is 950 in account A. Okay, then we are going to read the account B, that is 2000, and we are going to add 50, that is 2050, and we are going to write it in the B. Okay, suppose sorry, the end of the transaction, a a has 950 and B 2050, right? Okay, if any system crashes or failure during this operation, okay, this will be updated in the table and this will not be updated in the table. Okay, if the atomicity property tells that the operations and the particular process should be completely done, that is successfully complete the execution, or otherwise we have to roll back the process. Okay, that is for rollbacking process we have to maintain transaction log. Using the transaction log we are going to store the old values. So once we successfully executed the transaction, this value will change. If not, if roll back the process, this value will be in the database table. Clear? So next one is isolation. For isolation, for T1 process, the same. We are going to subtract 50 from the account and we are going to add it 50 in the B's account. In transaction 2, we are just going to add A account amount from A's account and B's amount from B's account. For example, if 1000 subtracted 50, so 950 will be in transaction after the completion of the transaction. Okay, in between the T2 is accessing A and B. Okay, the current value of A is 950 and current value of B is 2000. So after executing this statement, the result will be 2950, but actually it should be 3000, because we are transferring 50 from here to 50, because no, we are not executing this in between. The T2 transaction is interfering and accessing A and B account value, so it results in inconsistency. So isolation property says that once T1 started accessing A and B, it should complete all the operations, then only T2 can access it. If the T1 is complete all the operation, then T2 is accessing. Now this number, the 3000 will be the result. Okay, this is isolation. So durability in the sense, even after the system crash, we can able to retrieve the data from the database with the help of with the help of a component, a recovery management component. With the help of this, we can retrieve the value even after the system crash or system failure. I hope everyone can understand the transaction state and properties of transaction. Thank you.